Welcome everyone. In the last class, we learnt about mole concept in detail. In that, we learnt what is mole and what is moles of atoms and moles of molecule, and also we learnt the molar mass and atomic mass. In addition to that, we learned what is solution and what are the ways to express the concentration of the solution. So, there are many ways to express the concentration of the solutions. They are, so already we have defined these ways of expressing the concentration of the solutions. They are percent by mass, that is percent by mass is defined as mass of the solute is dissolved in mass of the solution. And then mole fraction, the mole fraction is defined as moles of the solute. So that the ratio between the moles of the particular solute or some of the solute and the total moles of the solution. In the solution there are solutes and the solvent present in that. And then we have defined the molality. The molality means it is expressed in the small m, and it is defined as the number of moles of solute present in kilogram of solvent. And the molarity is defined as number of moles of solute present in liter of solution. It is the unit for molarity is mole per liter, but for the molality is mole per kilogram. And then we have defined what is normality. Normality is defined as gravimetric equivalent of the solute present in liter of solution, which is expressed in the unit, denoted in the unit, that is gram equivalent by liter. Now we shall see how to determine these terms: percentage by mass, mole fraction, molality, molarity and normality, using a problem. Here the problem is given. I read out the problem. Given the mixture below, the mixture contains 23 gram of ethanol, that is molecular weight is equal to 46 gram per mole, and 85 gram of water, the molecular weight of water is 18 gram per mole, and total of 100 ml of ethanol or water solution or ethanol aqueous solution. So this is the data given in this problem, and the question asked in this problem is, the one is find the percentage by mass of ethanol, that is the question when asked, and find mole fraction of ethanol, 2 questions, and find molality of ethanol solution, 3 questions, and find molarity of ethanol solution. There are 4 questions asked in this problem using these data. Now we need to calculate these values using the data given in the problem. Now we shall find the solution for these questions one by one. The first question is, find percent by mass of ethanol. What is the formula for percent by mass? The formula for percent by mass is mass that is equal to mass of solute divided by mass of solution into 100. So this is the formula to find out the percent by mass. In this formula we need to give the mass of the solute and mass of the solution. We know we should need this data. In this problem here we have 23 gram of ethanol and 85 gram of water. So these are the mass of solute and mass of solution. And what is the mass of solution? Here if you take in the solution, lesser proportion is called solute and larger proportion is called solvent. So here the ethanol is present in the water, so ethanol is solute and water is the solvent. Here we need to find the percent by mass of ethanol, so that mass of the solute, in that the mass of the solute we need to give 23 divided by. So what is mass of the solution? Mass of the solution means mass of the solute plus solvent is called mass of the solution. So here the mass of the solute is 23 gram and mass of the solvent is 85 gram into 100. If we solve this, we'll get the value. Here we have 23 and 23 plus 85 into 100. If we solve this problem, we'll get the value 21.3%. So this is the percent by mass of ethanol. This is percent by mass of ethanol. So, and what is the remaining percentage of the constituent present in this solution? That is, the remaining percentage is in this 78.7%. This is exactly for water by weight. Next we shall find the solution for the next question. In this question they asked mole fraction of ethanol. We know the formula for mole fraction of mole fraction. The mole fraction is defined, that is equal to number of moles of some solute divided by total moles of solution. So this is the formula for mole fraction. Now let us find the solution for this. We know what is 1 mole of the particular substance or the solution. Here we need to give the mole of some solute. Here the solute is, in this problem, the solute is ethanol, already we saw. Here 1 mole of ethanol, so which contains, we know 1 mole is equal to, for ethanol we know the formula C2H5OH. If we calculate the atomic mass of these atoms present in the ethanol, and we will get 46 gram, that is 46 gram per mole. So which contains 1 mole of ethanol contains 46 gram per mole. But in the problem, the moles of the ethanol is not given. We need to calculate. So to calculate the mole, we have a formula, that is number of moles is equal to weight by molecular weight. So this is the formula to find the number of moles of a particular solute or the solvent. Here in this problem they are given 23 gram of ethanol is, that is the weight of ethanol, 23 gram. And molecular weight of ethanol. What is the molecular weight of ethanol? That is 1 mole of ethanol contains 46 gram. This is the molecular weight. It is also called as formula weight. So 46 gram. 46 gram per mole and 23 gram. If we solve this, we will get the value 0.500, cancels, gram is cancelling, getting mole of ethanol. Now we know the number of moles of ethanol present in this 23 and this solution, and also we need to know the total moles in solution. If you want to know the total moles in solution, we should know the moles of solute as well as moles of the solvent. We found the moles of the solute, that is ethanol, so that we need to know moles of the solvent. Thus here the solvent is water, so that we need to find the moles of solvent 2. 1 mole of water contains 18 gram. So 18 gram of ethanol. Likewise, we can calculate the mole of water here. Here the moles of water is, that is given here, that is 18, sorry, not 18. Here we need to give, we are going to find out the mole of water, so that we have to give weight by molecular weight. So the weight given in the formula is 85 gram of water. In this problem is 85 gram divided by, we know the molecular weight of the water, that is 18. If we solve this, we will get the value 4.72 mole. So it is gram per mole. So now we know the moles of the solute as well as moles of the solvent. Now we can solve mole fraction. What is mole fraction? We know the formula for the mole fraction already given. that is equal to moles of the solute. Here the moles of the solute we found, that is equal to 0.500 mole divided by the bottom. We have to give total moles of solution, so that we have to give the moles of the solute as well as moles of the solvent. So moles of the solute is 0.5 gram and the solvent is 4.72 moles. So if we solve this problem, or if we solve this, we'll get the value. We had it 0.096. So we got the value. This is the 0.096 is the mole fraction of ethanol. And what is mole fraction of the solvent present in the solution? That we do not know. So if you calculate the mole fraction, how you have calculated for the solvent ethanol, so solute ethanol, we can get the value. That is mole fraction for water molecule present in the solution is 0.906. This is the mole fraction of water present in the solution. Now mole fraction of solute is 0.096 and mole fraction of water is 0.904. The total mole fractions, if you see, if you add total mole fraction, if you add these two values, we'll get that is equal to 1. From this we can understand the mole fraction of all the constituents present in the solution is equal to 1. Whatever it may be, there may be the presence of 2 solvent, 2 solute, 3 solutes. There may be the presence of more than 3 solute. Also, the mole fraction of the total mole fraction of that particular solution always becomes is equal to 1. Now we shall move into the next question. The next question is find molality of ethanol solution. Here we need to find out the molality L. We know the formula for the molality. The molality is defined as molality, that is equal to moles of solute. Here the solute is ethanol. Moles of the solute divided by kilogram of solvent. If you see the problem, moles of the solute is not given, but we found in the last problem, so that we can substitute the value of moles of solute. The moles of the solute given, solute, that is ethanol, that we found as 0.500 mole. That is we found in the last problem when we are calculating the mole fraction. And kilogram of solvent present. So now we know the value of this. What is the kilogram? The kilogram of the solvent. Here the solvent is water molecule. The kilogram of solvent, the weight of the solvent is 85 gram. So kilogram of the solvent, the weight of water, that is equal to 85 gram, that is for water molecule. If we substitute the value, now we know the moles of this solute, that is ethanol, and kilogram of solvent. So both the values being known, so that if we substitute this values 0.500 and 85 gram, this is mole. When you solve this, we'll get the value 5.9 mole per gram. This is the molality of ethanol. This is also, this mole per gram also united as, the unit is changed into, does not change, we can represent like this, 5.9 molality, or the molar, or we can say this is 5.9 molar solution. Actually the 5.9 is 5.9 molal of ethanol. Next question asked in this problem is, find molarity of ethanol solution. We know the formula for molarity. Molarity, that is equal to number of moles of solute divided by liter of solution. So molarity is the ratio between number of moles of solute and liter of solution. We know the value of the number of moles of solute here is, already we know the solute here we have is ethanol. The number of moles of ethanol we found in the last problem, that is 0.5 mole, and number of moles of solution. Now how can we find the number of moles of, not number of moles of solution, that is present in the liter of solution. In this problem, if you see in this problem, 23 gram of ethanol and 85 gram of water, and total of 100 ml. Here the solution, the amount of solution we have is 100 ml. So we have to substitute this 100 here. Here we have total volume of solution. Volume of solution, that is equal to 100 ml. Now we can substitute this. This is in this, and we have to know that the liter of the solution, here the amount of solution is 100 ml. So it should be present, 100 ml is present in the liter of the solution. Solution, that is equal to 100 ml by 1000 ml. So this is present in the liter. So that we have to calculate this into the liter. So that we have to divide 100 ml by 1000, then we'll get the value into the liter form. Now we can calculate the molarity, number of moles of solute. We know the number of moles of solute, 0.5 mole divided by 100 or 1000 liter. If we calculate it, we'll get 0.100 liter, and here we have the mole, and the further calculation gives the value. If you divide these two values, you'll get 5.9 0. The unit of this is, so top we have the mole and per liter. So this is the 5 is the molarity of the ethanol solution that is present in this solution. It is also represented as unit for this molarity, also given as capital M. Here, or we can say this is 5.0 molar. If it is molality, we are saying that is molal. This is here in molarity, we say molar. So far you have calculated all the questions, that is all the concentration terms asked in the problem you have mentioned. And also we have to know another one thing, we need to note another one thing, that is in very dilute solution, if we have very dilute solution, for the very dilute aqueous solution, molarity becomes approximately equal to molality, because in very dilute solutions, that is the distance between the solute molecule and the solvent molecule gets increased, and also the distance between the solute and solute also increases drastically, so that it becomes more or less equal, molarity and molality. And also because of 1 liter of water is equal to 1 kilogram of water, so that if though two are approximately becoming equal, 1 liter of water also becomes is equal to 1 kilogram of water. So which means from this, for the very dilute solution, for that we have to add water only, so that we could understand the density of water is 1 kilogram per liter. So if very dilute solution, 1 kilogram becomes is equal to 1 liter. So far we learnt about how to calculate the concentration terms using a problem given here. Here we have calculated the concentration terms are percentage by mass and mole fraction, molality and molarity. Now we know clearly how to calculate these concentration terms. In the next class, we shall discuss how to calculate the normality of the solution and so on. Thank you.